This is a shiny app to help calculate Zymogen activation rates from chromogenic assays. A reaction mixture for this type of assay will contain a zymogen and an enzyme activator, in the presence of a chromogenic substrate. A new protease is generated from the zymogen and acts on the chromogenic substrate. At the early stages of the reaction, the production of the protease is approximately linear over time. This means that the rate of cleavage of chromogenic substrate is constantly increasing, which leads to an observed exponential increase in absorbance. In practice, to calculate the rate of generation of the protease from the zymogen, i.e. the zymogen activation rate, it is necessary to replot the absorbance data against time squared. The rate of zymogen activation is then calculated from the slopes of these plots. The idea behind the app is to perform this operation and show plots of absorbance versus time squared and generate a table of calculated slopes. These slopes are proportional to the rates of zymogen activation. More details about the calculations performed and algebra underpinning the time squared transformation can be found in the detailed help notes for this app. These are available from the Shiny Clots website and links in the Help tab of the app. When the app launches, a set of data is loaded, and it is useful to explore these data to understand how the app works and what the various settings do. When you are comfortable with the operation of the app, you can load your own data. The main body of the opening page opens with the Plots tab. There is an 8 by 12 figure of 96 plots from a microtiter plate assay. Data points are shown in red and calculated slopes are black lines. In this case, the zymogen was plasminogen, which was activated to plasmin by tissue plasminogen activator in the presence of a plasmin chromogenic substrate. Each column of wells is a range of stimulators of TPA. Other suitable systems could use streptokinase or urokinase as plasminogen activators, or involve systems that generate thrombin, factor Xa or kallikrein from precursor zymogens. Below the plots there is a table of results. The default settings show these results as rates of absorbance change versus seconds squared calculated from the plots. Because the rates are small numbers, they have been multiplied by 10 to the power 9 for convenience. The left panel includes a number of settings which control the way results are calculated. I will say more about loading your own data later. However, two very important settings here are number of points and maximum absorbance, which control how much of your data is shown and is used for the calculations. As mentioned above, the idea behind these assays is to calculate the initial rate of zymogen activation, which means in practice trying to use less than 10% of your substrate. In this case, there are two substrates, the zymogen and the chromogenic substrate. It is not so easy to calculate how to stay below this 10% threshold, but your aim should be to arrange assays where you have enough points to get reliable rates below an absorbance of 0.1 or 2. If you see the reaction rates of the raw data declining, then you should consider reducing activator concentrations or increasing substrate concentrations. The option you select in number of points and maximum absorbance allow you to optimize the calculations of initial rates for your data. The second tab, called Curve, is useful when trying to optimize your settings to get the best linearity of time squared transformed curves. Here you can focus on individual curves to find the best number of points and maximum absorbance for your data. You also have the option of looking at residuals for the fitted slopes using these radio buttons, and your aim should be to minimize the spread and systematic error of the residuals while having sufficient data to calculate slopes of the time squared plots. There are 4 more simple options below this. 0. The initial absorbance is useful for plotting if you have variable starting absorbances in your reactions. 0 initial absorbance will help with the appearance of the plotted curves if they have different starting values. Zeroing makes no difference to the calculated rates. The well names checkbox toggles between rate data and well names. The use time squared checkbox is ticked by default for Zymogen activation assays. However, if you want to use the app to calculate rates from simple chromogenic assays where you can control the number of points and maximum absorbance, then this is entirely possible by simply unchecking this box. It is possible to add a time delay to the data loaded if you are concerned about the time taken before starting your reactions and the first data reading. Below this set of options there is an area to set parameters to transform your simple slope results into a rates of Zymogen activation expressed as picomolar per second. The slope results are a relative measure of Zymogen activation rates in your wells, which is often all you need. However, calculating rates in absolute units of picomolar per second is more generally useful, for example when comparing activities of different activators. In order to calculate these rates you need to check the box that says calculate rates of Zymogen activation in picomolar per seconds and also provide some constants that are particular to your reaction system. You will need to determine these values for yourself under the conditions used in your experiments, meaning your pH, salt concentration and temperature, all of which affect enzyme activities. There are 4 constants you need to provide using the text input boxes in the bottom left of the app. These relate to the action of the generated protease on the chromogenic substrate. You need to provide the kcat and the km, which you will determine in a separate set of reactions. Please note that the units for kcat are per second and for km are millimolar. These constants will be determined in a set of reactions with a fixed protease concentration and varying chromogenic substrate concentration. Km is fairly simple to calculate for a protease with a chromogenic substrate. However, for kcat you will need to know the nanomolar concentration of enzyme you are using, and this is not always so straightforward. More details can be found in the help notes that accompany this app, and a link can be found in the Help tab. I am happy to answer further questions by email and my address is also in the Help tab. The other constants are the concentration of chromogenic substrate used in your Zymogen activation reactions and the absorbance value expected for a 1 molar solution of hydrolyzed substrate, which is usually the absorbance of para-nitroaniline cleavage product. I usually find a 100 microliter reaction volume in a microtiter plate would give an absorbance value between 2000 and 3000 absorbance units. However, you should work this out for yourself by fully hydrolyzing some low concentrations of chromogenic substrate and extrapolating to the absorbance value of a 1 molar solution. The absorbance will vary with different buffer compositions and also, importantly, with different reaction volumes. Therefore, please pay attention to this value. It is unlikely that your reaction system will also follow the default settings in the app. When you are happy with the operation of the app, you can go ahead and load your own data using the Browse button in the top left corner. Time course data, exported from a plate reader for example, should be formatted as a single column of time in column 1, followed by columns of absorbance data. The program detects the length and width of the data, so there is no need to specify these dimensions. Data can be read as CSV, text or Excel files, and the file type will be detected automatically. It is expected that all the data columns will have header text, time, well names, A1, A2, etc. The required format can be seen in the data loaded when the app launches by clicking on the Raw Data tab. Problems can often occur which cause the app to crash as a result of badly formatted data. Please ensure that your data contains no missing values or empty columns or rows, and avoid special characters. There is a lot to think about when performing Zymogen activation reactions to get the most out of your data. I hope this explanation of data analysis using this app is helpful. However, if you have questions or run into problems using the app, I am always keen to help. You can get in touch by email using the address provided in the Help tab, and please give the app name and version number along with an explanation of your problem. If you can provide a data file that is causing problems, that may speed things up. Good luck.